Let's continue. We are now in question number 3, still organic molecules. Remember, this one features the physical properties. So the boiling point, which is a physical property of some organic compounds, as shown in the table below. The atmospheric pressure is 101.3 kilopascal for this question. Now we are given 4 organic compounds. Quickly, we can just talk about the homologous series and the intermolecular forces. This one is a haloalkane, which has got dipole forces. This one is an alcohol, which has got your hydrogen bond. This one is a aldehyde, which has got dipole forces. Now, that's in a nutshell the analysis of these two. Now, define the term boiling point. That's the 3.1. Boiling point, remember, is a temperature. Melting point is also a temperature. Vapor pressure, just pressure. Now, this one will be the temperature at which the vapor pressure of a liquid equal to the atmospheric pressure of the surrounding atmospheric pressure. Find 3.2. They're saying to us, which one of the compounds ABC is mainly in the liquid phase at 100 degrees Celsius? Which one has not yet boiled at 100? It will be only one, is C. For the answer there is C. The other ones have already boiled at 100. And then explain the difference in the boiling point of A and B. A and B, remember, both haloalkanes, but if you look at B is having a branch. You can see now there's a branch CH3 in brackets. Therefore, it means that in terms of chain length, A will have the longer chain length. So there are many ways of answering this question. We'll go for the easiest one. To say, if I use a trend, I would say from A to B, one chain length decreases because you said B is branched, and then the second one will be the strength of intermolecular forces, IMF, decreases as well. And then the third one will be also the energy required to overcome the intermolecular forces decreases as well, because we are moving from the longer one to shorter one. If it was from B to A, it will be the opposite. That's where you get the 3 marks in this case. Explanation was 3 marks. That's how we get 3 marks in an exam. Yes. We'll move on. We come to the next question, which is your 3.4. 3.4, please careful. 3.4, they say to us, consider the boiling points below, 75 degrees Celsius, 120 and 126. Which one of these values represent X, the boiling point of compound D? Look at this one. Quickly you can tell that now X has got 4 carbon atoms and which one has got 4 carbon atoms? The first one and the second one. Therefore, the second one is branched, therefore the boiling point of X will be greater than B. But when coming to this one, the chain lengths are almost the same, but what the difference will be the molecular mass. And the molecular mass of A is greater than that of D. Therefore, it means that now A will have a higher boiling point than D. So if it's bigger than 46 but less than 78, you look at this one, therefore the answer will be C. The answer will be 75 degrees Celsius. 75 degrees Celsius. 75 degrees Celsius. 3.4.2, obviously explanation. Yes. We said in this case, first point, we said A, this one D has a longer chain length than B. That's the case. The second one will be now A has greater molecular mass than D. So that A is higher than D and D is higher than B. That's why we'll have the 75. I think that's the 2 marks that they're looking for. Yes. And then atmospheric, in this case, atmospheric pressure now changed to 83. Now, if it's changed to 83, they say, how will the boiling points of these organic compounds be affected? Choose increase, decrease, or remain the same. This one, we know that once you decrease the atmospheric pressure, it means that the boiling point also will decrease. So the boiling point will decrease. Fine. That's all about question 3. The boiling point will decrease. Now let's go to question number 4. Question 4 is about the chemical properties. Reactions now. Coming to reactions. Yes. Let's go. We are given this type of a question. This type of a question, which is very good. They are telling us to say, in an experiment, a test tube containing methanol, propanoic acid, and catalyst is heated with water. Obviously, we are in the process of esterification here. The water path is here and heated, and methanol, propanoic acid, and catalyst. Write down number 1. The name or formula of the catalyst. Remember, in esterification, the catalyst is sulfuric acid, therefore they are looking for that one. To say the name, sulfuric acid, or you write H2SO4. One of the two would be correct. Any one of these two would be correct. So write down the type of reaction. We said we are normally in the esterification here. It's not a problem. Esterification 4.1.3. Write down the 2 reasons why the use of water bath is preferred in this experiment. First reason is because alcohol is flammable. That's why we avoid direct heating. Number 2 will be to prevent overheating. Okay, that is fine. Then 4.1.4, write down the balance equation for this reaction using structural formulae. Must write methanol. Must write propanoic acid. 1, 2, 3, and this is the case. Then forms 1, 2, 0, 1, 2, 3. This is the cocoa part. The cocoa. If you're drawing esters, don't forget the cocoa part. It's always useful if you know that. And then remember, water, we are not obliged to write the structural formula. It's an inorganic compound, so we write only organic compound. The structural formulas here that are supposed to be written is for organic compound, not inorganic. Inorganic compound, just leave them as they are. Fine. We're moving to 4.1.5. Write down the UPEC name of the organic product for this reaction. Write down the UPEC name of the alcohol, of the ester. In this case, this is the ester. It will be your methyl propanoate. Methyl propanoate. Methyl propanoate. Fine. And then we move on to the next sub questions. And there are a series of very interesting ones are coming now, like these ones. Now they say to us, compound A has got 6 carbon branched a 6 carbon branched haloalkane is used in a 2-step reaction to prepare compound C. Fine. Therefore, this is part of 4.2. And then now we are given a hint. Reaction 2 is addition reaction. Yes, meaning that if it's addition, obviously they are telling us that compound B is an alkene, because addition is always coming from alkene. Therefore, write down the formula, name or formula of the inorganic reactant in reaction 2. If this one is an alkene, now we react with something, then form an alkane. C is an alkane, therefore this will require hydrogen. Therefore, it's either you write hydrogen gas, or you write H2. It's fine. 4.2.2. Then the next question, they say write down the UPEC name of compound B. We said B is an alkene. If it's coming from that one, therefore adding hydrogen means that the double bond was here. Therefore it will be now 3,3 dimethyl butane, or but 1-ene, 3,3 dimethyl but 1-ene. That will be the organic compound B. Yes. 4.2.3. Check. They say write down the type of reaction represented by reaction 1. Which reaction can form an alkene? Remember, that is will be obvious elimination. But we are going to accept also dehydrohalogenation. Because we are coming from this case halogenation. We are coming from haloalkane. Now 4.2.4. Let's check the next step. They say to us compound B is now used in two-step reaction to prepare compound A. Reaction 4 is substitution. We are given a hint. Reaction 4 is substitution, single, then move from single bond to single bond. And A, remember, is a haloalkane, so haloalkane can be obtained from alcohol or alkane. It's fine. Now let's go. B still remains an alkene, remember, which is your 3,3 type methyl but1-ene. Fine. Now they say write down the name or formula of the catalyst used in reaction 3. So if you move from an alkene and then come to D, so the reaction that might happen here will be a hydration. Why hydration? Because already I've got hydrohalogenation. It's out C. This cannot be an alkane, and then this cannot be haloalkane. So the best will be alcohol. If D is an alcohol, therefore reaction 3 becomes your addition reaction, which is hydration. And what is the catalyst in hydration? Is sulfuric acid. Sulfuric acid, or you write H2SO4. H2SO4. That is 4.2.4, 4.2.5. Now they say to us, write down the UPEC name of D. Therefore, D we said is an alcohol. If it's come from this but1-ene, therefore remember the rule will say hydrogen will go and bonded to the most bonded carbon. Therefore, this will give us now 3,3 dimethyl butane. Now butane 2-ol. It will be a secondary alcohol. Fine. And then 4.2.5. Let's go. What's that? 4.2.6. 4.2.6. They say name the type of reaction represented by 3. We said is addition. Obviously, it's coming from an alkene. Addition, or you can just say hydration. It's also going to be accepted, that one. And then 4.2.7. Now, if this one is a 3,3 butane 2-ol, therefore when we substitute it, the halogen will be at carbon number 2. Now they say write down the type of haloalkane represented by A. Choose from primary, secondary, or tertiary. And obviously, it's coming from secondary alcohol. It will be a secondary haloalkane. So the answer in this case becomes secondary. Secondary. So that is all about question number 4. Question number 4. So we'll meet in the next session for question number 5. I think that's enough. Very nice question, where now you have to follow the flow diagram. Very important. All the time analyze and make sure that one compound is not repeated in this case, or you follow the hints. Very good with the hints. Thanks, examiner. This was very good. Thanks a lot, and let's meet in the next answering.